Welcome to another video for chemistry. In this video we're going to be talking about gases, substances that exist as gases. This is a simplified explanation as to what a gas is, and it's the first of a number of videos that we get into gases and their properties, the ideal gas law, and so on and so forth. So let's go ahead and dive in here. So gases. What you have here is we have a column of air from sea level all the way to the upper atmosphere. And on Earth, because of its gravitational pull, you have an actual atmosphere. An atmosphere is basically a nice little layer of air molecules that surround Earth. And the most important being oxygen. Well, maybe not the most important, but a very essential one being oxygen because that's what we need to breathe. That's what we need to live. And all organisms on planet, thanks to cellular respiration, need oxygen to live. So, in any case, what I have here is a column representing a small section of that layer, that atmospheric layer. The top layer being the less dense, because as you get closer to the surface of the Earth, the gravitational pull of Earth has more influence on particles. So the lower you go down, the closer you get to sea level, the more dense the air particles are going to be. So you may hear about the air being very thin up in the sky where airplanes go, or up in Mount Everest. So if you're in Mount Everest, which is about the same elevation that an airplane flies, about 29,000 feet, you have very few air molecules up there that are needed for life. So you can live up to maybe 2 days or so in Mount Everest before you die because of that lack of air. So as I was saying, the lower you go, the more dense the air particles become, the more air pressure. Okay, you have an increase in air pressure, and what that means is that there's just more air particles surrounding you, pressing down against you. Okay, you can liken this to the water pressure in the ocean. So as you go deeper down into the ocean, you're going to have more water pressure. Okay, so if any of you like to scuba dive, you know that at sea level you have 1 atmosphere of pressure, and then every 30 feet or so, every 33 feet or so, you have an increase of air pressure of 1 atmosphere. So in any case, if you're down at the bottom of the ocean, you would have all of the weight of the water on top of you pressing down against you, and you would literally be crushed. So that's similar to the air pressure up at sea level, except for the fact that there's not so much that it crushes you, but it just keeps you intact, if you will. Okay. And by intact, I mean you have pressure. There's pressure that's pushing out inside of your body, which is equalized by the pressure that's pushing against your body from the outside. So it keeps you intact. So increase in air particles as you get down lower. So at sea level, we call that 1 atmosphere of pressure. Okay, that's a standard pressure for planet Earth, 1 atmosphere of pressure. Okay, and we'll get into that a little bit more as we go along. So what is the difference in gas and a solid? So again, this video is just a simplified discussion of gases. Okay, so what makes a gas a gas? These are some of the questions that we'll be discussing in this video. So we can answer the above in a single word. Okay. Intermolecular forces, and I guess that's 2 words really, right? So the difference between a gas and a solid are the intermolecular forces, and those forces are: the stronger these attractions, the less likely a compound can exist as a gas at ordinary temperatures. So what that means, these intermolecular forces, is that as a compound collides with another compound, as they come in contact, are the intermolecular forces strong enough that when they come into contact, they stay together? Or are they weak enough where when they collide, they just bounce off of each other and then remain as a gas? Because if you have enough of these molecules that bounce and come in contact with each other, and they attract and they stay together, if you have enough of these that stay together, you eventually form a solid. Okay? So an example, carbon dioxide. Carbon dioxide we know to be a gas on the surface of the Earth. Right? There might be other planets in the solar system where carbon dioxide is a liquid because of the different varying pressures and gravitational pulls of planets. But on Earth, carbon dioxide is a gas. Carbon dioxide at STP meaning standard temperature and pressure, okay, collisions with other CO2 molecules, They happen all the time. And again, the question is, are the intermolecular forces strong enough to keep them together, or do they just collide and simply move on? Well, as we know, they just collide and move on, and they remain a gas. So CO2 remains a gas in our atmosphere. Okay, we exhale CO2 all the time. So the intermolecular attractions are not strong enough to create a bond. So they remains into a gas state. And here are examples of other molecules that are in a gas state at our STP. So H2, molecular hydrogen, N2, molecular nitrogen. 78% of our atmosphere is nitrogen, and then molecular oxygen, O2, and then O3 is ozone. Okay, F2, molecular fluorine, helium, neon, nitric oxide, nitrogen dioxide, sulfur dioxide, and methane. These are all examples of molecules that have very weak intermolecular forces, have very weak electrostatic forces, so that when they collide with each other, they don't bunch up and create a solid. So there are three states. There are solid, liquids, and gases. This chapter is dedicated to gases. And here you have a picture of, do you know what it is? Yes, it's carbon dioxide. This is solid carbon dioxide or dry ice. This is stuff that you can buy at your local market. Dry ice is basically carbon dioxide that's been solidified by changing the temperature, lowering the temperatures so much so that when carbon dioxide come in contact with other carbon dioxide, they actually stay together and form a solid. But then when you take that carbon dioxide, that solid, that dry ice, out into normal atmosphere, it sublimates and goes into a gaseous state immediately. And that's what you see as that nice little fog. Pretty cool effect. So STP, again, STP meaning standard temperature and pressure. And that's what we experience at the surface of the Earth. Our standard temperature and pressure is 25 Celsius or 273 Kelvin, okay, and 1 atmosphere of pressure. So again, we're going back to those electrostatic forces. They're very different when you compare a solid to a gas. On the left, you have carbon dioxide. Those electrostatic forces are very weak. That's why carbon dioxide remains as a gas. And then sodium chloride, those electrostatic forces are stronger, which when you have one salt particle, one salt crystal, connect with another salt crystal, they typically stay together because of those electrostatic forces. They are strong enough to keep them together. Okay? That's why you form solids as opposed to gases. So let's talk about the physical characteristics that make up gases. So they assume the volume and the shape of the containers. So no matter what the container, no matter how big or how small, that gas will fill up the every square inch of that container. Gases are the most compressible of states of matter, so you can compress them. In fact, if you go by your propane at a gas station, when you shake up that tank, it sounds like there's a liquid in there. Well, what's happened is that they have the gas compressed in there so tightly that that gas actually forms a liquid, okay, before you take it to your grill and fire up your barbecue. Also, they evenly mix and completely mix when confined to the same container. And an example of that would be oxygen tanks or your air tanks when you're scuba diving, okay? And they have much lower densities than liquids and solids. Okay, so they weigh almost nothing. And you have hot air balloons. When you heat up the air, those gas particles expand. They don't expand, but they gain energy, and their densities become a lot lower than the air that surrounds them on the outside, which is what causes them to be so light and to float up into the air like your hot air balloons. Okay, well that does it for our introduction discussion of gases. So I hope this was helpful. Good luck in your study.